Hey guys, welcome. This is the Autonomous Database Learning Lounge. I'm Marco Sanasibia. I'll be hosting the call for you guys, and I'm part of the product management team for Autonomous Database. And today we have a very cool session on how to actually work and create an application and connect that with an Autonomous Database and use all of the benefits that Autonomous Database brings to you, right? So we're going to take a look at, how Autonomous Database actually changes the way you build applications, all right? So for the agenda today, we have I'll be starting, right, and giving you guys a very quick, brief explanation of what Oracle Autonomous Database is, if you guys are not familiar with it. Then we're going to have Marty Gubar, our Director of Product Management, and he's going to show you guys how to basically simplify, the success path to analytics using the Autonomous Database, right? So he's going to show you guys how to discover, integrate data from different data sources and different clouds even, right? How to develop interactive dashboards, identify high-value customers at risk, right? And then personalize recommendations, right? And at the end, he's going to talk about how you guys can find materials, right? Everything that we have, all of the assets, right? Links to documentation and things like that. Throughout the session, we're going to have an open Q&A. So at any time, if you guys want, please make sure to ask your questions in the Q&A feature of Zoom, okay? We have Kit Laker and other product managers listening in and watching what your questions are, so we can make sure to answer any questions you guys might have, all right? And we're going to make sure that the recording is going to be made available by the end of the week. We're going to put it on YouTube, and we're going to put the links in Ask Tom. And we're going to have actually another page where we have all of those links and slides and things like that, okay? So what we're going to do then is I'm going to start very briefly on a primer on Autonomous Database real quick so that we can give Marty the space, right, that he's going to need. So basically, Oracle Database, right, as a whole, I think you guys are very familiar with it, and I expect you guys know, has been around for a while. When I joined Oracle, we were at release 11. I used Oracle since probably release 8, but release 11 was more or less when I joined. But there's a big evolution, right, on the Oracle database itself, and every other customer that we've seen on the planet here uses Oracle database, right, for something. So that's clear. So what happened with Oracle then is we created a very large ecosystem, right? So from development tools to analytics and data visualization tools to data modeling and data integration tools, all the way to industry solutions, right? We are basically very wide open, and we make sure that we integrate with all of these tools that are available, right? So Oracle is a very, very key and important tool, and basically that's a broad range of things that we do. So with that evolution, basically what we have done is we have taken all of that evolution and that intelligence, and we added that in a completely new way of delivering a cloud service. So we said, let's leave people without the worry about the infrastructure, without the worry about the database itself, right? All of the core, all the software, the components there, and leave people without the worry about any of the operations they have to do, right? Taking care, patching the database, working with the database backups, all of those things. And let's automate that. So basically, that's what Oracle did. So we created an Oracle Autonomous Database, right? It's available in the public cloud. So in shared infrastructure, we have a dedicated infrastructure option as well. We have it on private cloud, so you can actually have it running on your premises, on your data center, using the Exadata Clouded Customer or the dedicated region Clouded Customer, and available in multi-cloud. So for example, Azure customers today have a page where they can go there, and then they can actually provision an Autonomous Database, right, and connect to it from the Azure interface, right? So the idea for the Oracle database was make it simple, deliver the modern data-driven applications and analytic workloads in the cloud, right? That was the idea for our Oracle database. So what we have done is then we have delivered this entire infrastructure and allowing you guys to use many types of data. So from relational to documents to graph to text to spatial, so all of that different types of data and a lot of different workloads, right? So everything from IoT and microservices, right, to machine learning and social graphs and location. So there is a lot, right, that the autonomous database and the database behind it can accomplish, right? So we created actually 4 different optimized platforms, right, for different workloads. So we have a data warehouse. So there's an autonomous data warehouse that's built for decision support, right, and data warehousing workloads. So there are optimizations there. At the core is the autonomous database, but it's optimized for data warehousing, okay? Underneath, we have the transaction processing. So the autonomous transaction processing, ATP, that's built for transactional workloads, so optimized for that. But again, it's the same core of the autonomous database, just optimized for that. On the top right, you have Apex, right? So the Application Express. We have a specific Application Express version of the autonomous database as well. And then a JSON one, right? So built for JSON-centric, right, application development. So it's a more JSON-friendly environment, right, and developer-friendly environment for document APIs, right? So all of these guys are built on top of the autonomous database in its core, right? And autonomous database is running on top of Exadata, right? Our best hardware platform, right, if you will, for Oracle database, right? So at the end of the day, the idea for us is we have to be able to cover any data. So it's using the converged database, right, infrastructure, any workload, and then any development style, right? So we got APIs for everything. Think about Python, you know, Mongo, whatever language you're working on, you're going to find an API, right? REST APIs of all kinds, right? So with that, thank you very much, guys, for the support here. Thank you, Marty, for joining us. I'm going to stop my sharing and going to let Marty Gubar share his screen. And again, thank you, Marty, for joining us today again. And take it away.
All right. Thank you, Marcos. Hey, everybody. I have a lot to cover today. So my name is Marty Gubar. I'm part of the product management team. And so what we're going to do today is I'll start by providing just a quick introduction, and then we're just going to dive right in. And we're going to dive into what we think is really the best way to build smarter applications and make it easy to build those applications. So by smarter, I mean using analytics to make your applications more effective. So in our case, we'll be targeting the right products to customers, targeting special offers to those who might be at risk, and a lot more. So, you know, just to start, you know, people within organizations often have differing primary goals, right? So, you know, think about developers. They want to get to work. They want to focus on the now, right? Building compelling applications using simple APIs, whether it's a document database or a graph database. They're very focused on ease of use for that backend, for that API, whatever it is going to be to make it simple to develop their applications, right? Oftentimes that leads to single purpose databases. Now, CTOs, well, they have similar interests, right? But they're also thinking about the bigger picture. Like, this is one of many applications that they need to manage. And CTOs are very interested in common tooling and management, governance, using that data that's generated by the application and combining it with other enterprise data, third-party data to improve decision-making and frankly, running the business. Now, this doesn't have to be a choice. You don't have to sacrifice one for the other. And that's what we're going to talk about today, right? That you can improve both developer productivity and data productivity. So how can that be done? Well, we're going to go step through a scenario called Oracle MovieStream. And for Oracle MovieStream, analytics play a critical role in the delivery of their application, right? So it's an online movie streaming service. It's fictitious online movie streaming service. And MovieStream, look, they face many of the same challenges that so many of us here face, right? They're in a very competitive environment. And if a customer can't find a movie that they want to watch, they're gone, right? In just a few clicks, and they go to another service. Acquiring new customers is costly. It's not easy. So it's really important to retain existing customers. And to retain existing customers, right, they need to make sure that they're providing a really good product at a great price, but they also need to make sure that they're making the most out of whatever their marketing dollar, right? So as a result, to satisfy that, right, MovieStream's built a lot of intelligence into their application, right? So on the top here, you can see that machine learning, right? That's used to predict customers that are at risk and then make a localized offer. In this case, we'll be looking at making a pizza offer for people who are predicted to be at risk. We use analytic SQL, right, to determine the most popular movies in the service. We use analytic SQL plus spatial to say, hey, what are popular movies near you? We use JSON analytics to query complex types and rank and combine JSON data with transactional data. And we also do graph analytics, right? They used to make that personalized experience, right? To make recommendations of products based on my personal viewing patterns. We're going to show you how all of this was done, right? And there's a lot. So don't worry. There's two things I want to get across. First is we have what's called live labs, which are workshops. And if you go to bit.ly/adb-workshops, and we're going to put all of these links in the chat so you'll have them. We show you how to build this. You can do this yourself, either in an always free environment or in your own tenancy, your own cloud account. The second thing is we have simple demos, right? So we have a page on bit.ly/adb-demos that step you through all the things that we're going to go through today and a lot more. So we're going to be going through a lot. It may be a lot to keep up with, but don't worry, you can always go back, right, and learn more. All right, so let's start with actually building the application, right? Now, the front-end development team, their real responsibility is developing that compelling user experience, right? They need a productive, easy to use, fast, reliable API to drive the site, right? It's got to be always up, always on. Honestly, the front-end team doesn't really care or have the time, frankly, or the experience to focus on perhaps the actual content and how it's being derived. In other words, like they're making a REST call, right? They're making a call to a REST endpoint. And all of the sophistication behind that is actually encapsulated within the service, right? So what we've done with Autonomous Database is we make it easy to build applications. In this case, we built a Node.js application, and it's using a REST endpoint. We could use MongoDB APIs as well. So ADB supports MongoDB. We also have low-code development with Apex. So we have lots of choices for delivering your applications. Now, if we take a look at what it looks like for the REST endpoint, so Autonomous Database, you open up the REST endpoints and you make simple calls against ADB, let's say, to get all of your notifications. So here you simply pass to a collection. We have a JSON collection. We say, hey, give me all of the notifications. So the API is looking for a specific customer ID. And what's returned is a JSON result that you pull into your application. And as a result, we're seeing, here's the special offers made to Emilio because Emilio is predicted to churn, predicted to leave. Painting the page, right? When we're painting the page, you have what genre should be displayed. What are the shelves? So list out all of the shelves and the ranking of the movies within those shelves and the descriptions and all that, right? All of that's returned by a simple API call. How that was generated behind the scenes, as a front-end developer, I didn't necessarily care, but you know who cared? This person. This person is the REST endpoint, right? So in order to derive or to drive the best experience possible, she needs a lot of information about customer interests, their backgrounds, their behavior on the site, because each customer is getting a customized content, right? So she's working with the marketing team to identify customers that are potentially going to churn. They're going to leave for a competitor. And we want to do, and with that knowledge, make a compelling offer to stay. Now, marketing dollars are tight, so prioritization is going to be important. We're going to show you how all this is done. Now, driving that innovation using all of your data can be tricky, right? It can be a big task because data architectures typically are using relational databases, data lakes, NoSQL stores, you know, the gamut, applications. And so it's different types of data in different formats, stored in different systems on different clouds, on premise. So in order to do these analytics, you need to start with an integrated view of your data. And you need to do so economically and efficiently. So that's kind of the key. Like this is like the mission for autonomous database is to simplify your use of data, right? So we want you to be able to do more with all of your data. That means finding data sets that are of use. It means understanding the meaning of that data, right? It's not enough just to have columns and tables. What's the semantic behind that? Collecting that data from different sources, integrating it and wrangling it and matching with the data sets that you have so you can organize it and then analyze it effectively. And then once you take those analytics, once you produce those analytics, well, I have someone who I've predicted may leave, or I have product recommendations. How do you then operationalize it and apply those insights to improve your business process or to mitigate risks? That's it, right? So above all, like what we're trying to do is making steps 1 through 4 here simple and provide an integrated system that just runs all the time, runs well, and safely, right? So that's kind of our mission. So we'll step through now how MovieStream built their app, right? So we'll start by, and really focus on how they're integrating the analytics into the app. So we're going to start by integrating customer and movie data and activity data from MovieStream's data lake. Okay, so they have a data lake, and then they also have partner data that's on S3. Then we'll start analyzing that data. So you can see how the shelves of the application are actually created, right? We'll find popular movies near you. We'll show you how we combine JSON with transactional data. And we'll also see which customers have left. Now, how do we get in front of that and prevent people from leaving in the future? And that's where we're going to look for new data sets that will help us perform an analysis, which is creating a machine learning model that predicts churn, right? And then make pizza offers to those that qualify. Now, we'll publish a new data set and we'll unleash the power of ad hoc analytics with Analytics Cloud. And we're gonna, one of our shelves has the Academy Award, so we're going to be looking at, what is the breakdown of movies and sales for across different customer segments during the Academy Awards and what is the impact of the Academy Awards. And finally, we're going to look at step 6. What are the best movies to recommend to our customers? And we're going to take that result and feed it back into the application. And hopefully you'll see that integrating all these analytics into a single place and combining it with the transactions makes for a really productive experience, right? It's easy to publish, and you'll be able to see how that customer experience is updated. So let's start now with step 1. We have data in different stores, right? And so what we're going to step through is a simple user experience using what's called Data Studio. So it provides a really simple user interface for linking to, for loading data sets, but also for linking to external stores. So a link is the data stays in that source, but we're querying it dynamically. So imagine having querying your data lake dynamically. So as the data in the lake updates, you don't have to do a load. You're just going to access that data dynamically, or you can load that data. Now, we're going to be loading data from both AWS as well as from Oracle's data lake. And we'll also show about linking data. So underneath this UI, frankly, is a whole slew of APIs, right? So you can do things through the user experience, but there's a rich set of intelligent APIs that understand that you're actually talking, in many cases, to a data lake, right? So it'll understand things like partition data sources. It takes it, there's rich security support, regardless of your source, right? So we create credentials to be able to access S3 or Azure, right? And so we fit into the security models of the underlying, of the target cloud, right? You have APIs for loading data, linking data, exporting data, moving data, the works. So it's a really full list of APIs. So let's do this now. Let's show how to integrate data across clouds. So we're going to start where we have both data on Oracle Cloud as well as data on S3. And this is what it looks like. This is the autonomous database landing pad on OCI. And you can see that there's all different types of actions in database actions for running SQL, testing your REST APIs, working with JSON, data catalog, administering users, managing your database, and more. But what we're going to do is start loading data. And we're going to load data from our cloud store. In this case, we have a data lake, and we have data stored in a gold zone in a bucket. Okay, so there's 4 different folders within that bucket. We have customer contact, customer sales, genre, and movie. So we're going to just load it all, right? We're going to drag and drop customer contact and all the files that are within there. And what's nice is that when you load it, not only are we loading data, we're going to create a table from that source. And it automatically derives the column names and their data types, right? So it's smart. And that's for different types of sources, right? So that was a simple CSV file. Customer sales is partitioned Parquet data. That's fine. We also have JSON data and CSV data. We also support Avro and ORC and XML, like tons of different sources. Now, movies are in JSON. Oracle's got great support. We have a JSON version of Autonomous Database, right? So what we're going to do is, because we have all these great JSON capabilities to analyze JSON data and to work with JSON data. So we're going to create a brand new collection from our movies. So a collection is, we're actually going to store documents into Autonomous Database in a very optimized way. So now we're just loading that data from these sources. And what we've done is we've just created 4 tables. We can take a look at genre. It's a table with these values. You could see action, adventure, animation, biographies, it's done, right? We've just now loaded data without having to write a line of code. So part 1, we've now loaded data from OCI. I just skipped ahead. We also went through the process, a very similar process, and I'll just keep going, of loading data from S3. S3 is going to look just like Oracle Cloud, right? And you can look at the demo videos. So what the one difference is that we're going to create a credential that identifies Oracle Autonomous Database as an Amazon resource name. So you can then grant access to Autonomous Database to different data sets. So in our case, we loaded pizza data, which came from a third party from Amazon, and loaded that in. So sorry, I just skipped that, but it was that's a step that we would just gone through. Okay, we've loaded our data. We have pizza data from S3. We have other data from Oracle Cloud's object store. Well, now we're going to do some more analysis, right? And frankly, understanding the meaning of data in your data sets can be hard, right? What content is in a given table? What do the fields within that table mean? Like, when were they last updated? Are they reliable? So OCI Data Catalog is a metadata management service that helps you support data governance, right? So it provides an inventory of assets, which could be from a database, it could be from object stores, it could be from streams. And it provides a business glossary and a common metastore for data lakes, right? So you can think of it as being like the spotlight for OCI that lets you search for and understand your data sets. Now, once you've harvested, and we're going to look at it, the one aspect of the data catalog, and that's how does it integrate with data lakes, right? Because, for data lakes, there's not necessarily a schema associated with data in a data lake, right? It's called schema on read. So what data catalog will do is it derives the data schemas through what we call a harvesting process. It's going to scan all these files. It's going to derive tables from these files and columns and their data types. And then once you harvest it, you manage it. You apply terms and your business glossary to what's been captured, right? So now that you have an understanding and a meaning of the data sets, right? So there's someone who knew the data sets, it was telling you what they are. Well, now you can search for them, right? So find data sets that might be of interest to you. Understand those data sets. So there's very rich search capabilities that are provided by the service. Okay, so data catalog went through, it scanned the object store, it derived all these tables from data that's in your object store. Well, the next thing is, now that I have that metadata, remember, it's just metadata. I'm going to synchronize that metadata automatically with Autonomous Database. What does that do? Well, what happens is managed schemas are created and tables are defined automatically in Autonomous Database that match the metadata that's here. So now I have tables, external tables. The data is stored in object store. All the data is in the cloud. And now I can just start running queries from Autonomous Database using Oracle SQL against the data lake. No management's required here. The data is automatically available, and you can blend that data with data that's stored inside your database. So you automatically blended data in your lake with data that's in your data warehouse. It's pretty cool. Now, what that means is you're using Oracle SQL against anything, right? You're using Oracle SQL against your lake, as well as Oracle SQL and other types of analytics against all your data, right? Machine learning, graph analytics, stats, and more, right? So this is really important. Why? Because you have with Oracle SQL a declarative approach for accessing and analyzing your data. You don't have to write code, right? Think about like you want to understand how someone is navigating your website. How much time are they spending on each page, for example, right? Write a Python script, go through the logs, and check that out, right? You capture how much time is spent on each page, et cetera. Or that's code, right? That's probably hundreds of lines of code to do that. Or write a SQL query, right? A SQL query that does SQL pattern matching. Iterate over, you just write your select statement, try again, and you can now use SQL to create sessions. Use SQL to figure out how much time they've spent on each page. Use SQL to combine that now with other data that's in your warehouse, right? It's pretty, you can very easily fall off a complexity cliff, right? If you don't have a powerful SQL language. So what we're now going to do is say, let's look at this data that we've collected. We're going to actually have to look for more, because what we're going to find is potential issue, right? We're losing some high value customers, and we'll want to get in front of that and say, well, how do we prevent it going forward by making specialized offers? Okay, so we're going to use our notebooks, which are in Autonomous Database. With the notebooks, you can use SQL, Python, R, different languages, PL SQL. So if you remember, we loaded movie data that was in JSON format. JSON's really powerful. It's very flexible. JSON's also kind of complex, right? So this is what JSON looks like. I have a list of studios, so I have an array associated with studios. I have movie titles. I have the year. All of it's embedded within this content. This is called a JSON document. So each movie is a document. Well, pull out the information that you need, the movie ID, the title, the year, using simple dot notation. And there's a lot more. This is like the simplest SQL you can do. But what we're doing, and we can do a lot more with, looking at arrays and turning arrays into rows and tons of stuff that we can do. But now we have data in JSON format that's accessible and can be analyzed, right? You have columns. Hold on to that. We're going to use those movies, because what we're going to do is we're going to build a shelf with the movies, and that movie shelf that says what's popular near me, right? So to do that, you need algorithms that say, well, who's my nearest neighbor, right? So what we're looking at here is a spatial query that's saying, I want to find the nearest neighbors to me. I think we're doing near Roberta, right? So you're able to use specialized functions that give you your nearest neighbor using latitude and longitude, right? Not saying, hey, who's in the same city? We're going to use latitude and longitude and to figure out who my best customers are, or who's near me. Now that I have my customers who are near me, and I know how to pull out those movies too, well, I'm now going to say, I'm going to combine it all. Who's near me? Take those movies that they're watching and combine it with the transactional data. And these are the most popular movies near Roberta, right? So we combined all of these things, analyzing JSON data, using spatial analytics over that, combining it with transactional data to produce that nice little shelf that says, what are people watching near me? And her neighbors love action adventure. And her shelf is now populated. All right, so the next thing we're going to look at is, what's up with our high value customers? We do what's called an RFM analysis. We're going to find customers who have been heavy users of the service. And we're actually going to take all of our customers and we're going to bucket them into 5 buckets. 5 is heavy users, spend a lot of money, and they come frequently and recently. Now, if you have a score of 1, they haven't come recently. So now we're looking at customers who are high value customers. They spent a lot, they used to come a lot, but where are they? Why haven't they come? All right, well, we want to find out. These are customers that we probably have already lost, right? They may have moved on. So what we want to do is figure out, well, who's potentially next. And to do that, we need to better understand our customer profiles. And we're going to use data that's in the lake to help do that. So let's go to data catalog. That's Spotlight for OCI. And we have data in our lake, and it has all this information about customer demographics, customer segmentation. But data in the lake they're files, right? We need to make sense of that data. So what we're going to do first in data catalog is harvest it. And you can harvest data from databases, data lakes, lots of different stores. So what it's going to do for the data lake is turn those files into meaningful pieces of information. It's going to turn them into tables and columns, right? And so we're going to run through a job that scans these files and generates those results. Okay, so we had done it already. Now that it's been done, let's see what it found. Let's see what's in our data lake. So we have multiple assets. We have a data lake and we have a data warehouse. If I look at the landing zone, there's lots of tables here. Customer contact, customer segment, customer extension. Well, if I look at customer contact, well, there's some good information there. It's got all of these different attributes. I have a customer ID. I wonder what that is, right? So I can look at customer ID and see the term that's associated with it. Oh, customer ID, it's a customer identifier. And in the glossary, this is the unique identifier that's in our CRM system, right? And it helps you understand the data that you're looking for. So I'm searching for customer, and here's all the customer information across all my data sets. And one of the things I found in data catalog is customer demographics. This came from a third party and it's approved for analytics use. And if I look at customer extension, it has all sorts of nice attributes about customers that I can use to build my models to help me understand who my customer is, right? So that data is now available, right? And I can now access, I can even see the metadata that's in data catalog. And that customer demographic information is called customer extension. I can now even query through SQL. I didn't load it. The table's automatically available. Here's my information about customers coming from the data lake. Lots of interesting attributes like household size, income level. Do they have a pet? Do they own information? And now I just run Oracle SQL over all of that data. And frankly, I combine that data with data that's in my warehouse, and I can see here that millennials are kind of our most important customer segment. All right, well, I'm going to take that, and ahead of time, we went into one of our data scientists went into AutoML and created a model, a churn model. So in creating that churn model, we're now going to use Python to score our customers. We know who already left, who might leave, right? Who's at risk? So we created a churn model, and we have a prediction of customers and the probability that they may leave. Now, it's too expensive to give everybody a free pizza offer, right? So what we're going to do is we're going to look at our high value customers that are predicted to churn. Now, if I look at Emilio lives near a pizza place. So we're looking at customers that live near one of our pizza locations that are at risk of leaving. They're a good candidate. Lee, well, Lee is far away, and he's not going to get the offer. So now that I have this data in my warehouse, I have all this data easily accessible. You can use whatever tool you want to analyze that data. Analytics Cloud is a phenomenal application for analyzing data, right? And that's what we use here. But you could use Tableau, you could use Power BI, you could use other things. But Analytics Cloud is great because it leverages many of the strengths of the Oracle database. And it's highly interactive. It's really easy to use. It empowers like business users, data engineers to, and citizen data scientists really to connect to different sources, prepare and enrich all their data, and then analyze it in a really easy way. I'm not going to demonstrate it right now because we're kind of running out of time, but there's videos on the demo site where you'll be able to go check that out. But what we are going to do next is actually show what recommendations should we be making to customers. And we're going to use a graph analytics to do that. And graph is a little bit different than what you may be used to. It's all about connectivity. I'm friends with Marcos and Keith, right? We have a friendship relationship. Maybe it's a relationship about what they're viewing, right? So it's about pointing entities to one another. Keith watched this movie and that movie and this other movie. Based on what people are watching, we could form communities, right? And we're going to make our recommendations based on these linkages. You can use graph for so many different things, for predicting, identifying fraud, all sorts of great applications, finding who are influencers in a group, because you probably want to target influencers. In our case, we're going to be using it to make product recommendations. So within Autonomous Database, and everything I'm showing you is part of Autonomous Database, we created a model, a graph model, which is basically what we just described, who's watching what, right? And now that we've created this graph model, we go back into our notebook and we're going to use something called PGQL. PGQL is very SQL-like, but it's kind of extended for graph, right? So it's saying this customer, I want to find the customers and what customers did they watch? What customers watched a particular movie? Notice the directionality in this query. So for Emilio Welsh, he watched My Fair Lady and Gladiator, an interesting pair. But you can see this is the edge and this is what he's connected to. Well, what has both Floyd and Emilio watched? Again, there's directionality in that query, and you can now see the entities, the movies that they're both watching. Imagine this now on a scale of hundreds of thousands of users, right? Well, it's hard to visualize. So what we're going to do is we're going to use an algorithm, a personalized salsa algorithm, which is going to rank movie connections based on connectivity strength, right? So we're almost like forming these communities. And based on that, we can see that, you know, what have people in my community watched that I haven't? Here's the recommended movies based on that and the strength. So Avengers, Guardians of the Galaxy, Jurassic Park. Here's the ranked recommendation results. And what I'll do is I'll feed that back now into my application. I'm going to save these recommendations back into the transaction database. So I'm going back now to the transaction MovieStream itself. I hit refresh on that page. And what we're going to see is, well, Emilio now has new movie recommendations because he was predicted to churn. He qualified for that pizza offer. And he's also now seeing all of the movies that are recommended to him based on his viewing patterns, based on his personal community. So that was the whirlwind tour, right? And again, we covered a lot of ground. able to get a view of how MovieStream leveraged different types of analytics, all included within Autonomous Database, to make a better service and to help you make better decisions and put your data to work. So there are lots of live labs and demonstrations that can help you learn this. And I'm going to step through that now. But our goal, again, the key takeaway is that our mission is to simplify. Help you put your data to use, leverage all of your data to make better decisions. So, hey, unleash your creativity, unleash with just like a really simple self-service tools, right? That provide powerful analytics and so that you can get better results. And, importantly too, the days of managing your system are just in the past, right? We're making the data platform 99.995% available and it's safe. So you focus on innovating and using your data. All right, so here's some important links that I want you to know about. First of all, everything we did today, you can do yourself. So sign up for Oracle Cloud. You can get a $300 credit. If you've already used up your credit, it's okay because you can use the always free Autonomous Database. That's part of your service. It's always free. Everything that we've done, you can do in the always free service. There's a getting started guide. So bit.ly/getting started. And again, Keith, I think pop all these URLs into the chat. So great content on how to get started, whether it's looking at blogs, the live labs that we have here. So the live lab that we spent most of the time on here is integrate, analyze, and act on all your data. So there's all of these workshops that you can now do yourself. And you can also watch demos. If you don't want to put fingers to the keyboard, that's fine. You can watch these videos yourself, right? And there's everything that we just stepped through as part of the demos, plus a whole lot more. So bit.ly/ADB demos. And here you could snapshot this page, which has all four. Finally, you want to keep up, right? What's up? What's new? So the Autonomous Database Insider, Keith, does a tremendous job of keeping us all up to date on the new features that are available in Autonomous Database. We've had over 100 new capabilities just in the last year. It's a fast-moving service. The mission is to make things better quickly, make things easier. We also have a LinkedIn channel, bit.ly/LinkedIn-ADB, as well as a Twitter, so @AutonomousDW. And finally, here's the link that you may want to, or here's the page that you may want to snapshot. Lastly, get inspired. Get some great ideas from our customers. And we have hundreds of customers. If you go to bit.ly/ADB customers, you can see for yourself how our customers are succeeding with the platform and putting all of this to work. That's what the whirlwind. I thought I'd be able to get this done faster today, but than yesterday. But I think I did the same, Marcus.
No, that's great.
Get to the end.
That's great. That's great. Thank you very much, Marty. All right, guys. So if you want, we have the Q&A channel open. So make sure to type in your questions. We have already answered a few questions there on the different topics. So thank you, guys. This is great. Final thoughts on my side. So we have our main Autonomous Database site. We have, again, a few of these links. We're going to make sure that they make it, and most of them are already there. So if you look at the right-hand side where the page that you guys used to join today is, right? The Autonomous Database Learning Lounge, we have that on the session resources, right? So those guys are these links that you see on the left-hand side here. And make sure to subscribe to the next sessions, right? So as I mentioned, we intend to have a session every 15 days, so every 2 weeks. So the next session is going to be on Data Studio. And I see a few of the questions there. The bit.ly URL for the sessions and for the series is just that one on the top. So bit.ly/adb-learning-lounge. Okay. So with that, you guys can see exactly that screen, subscribe to the next sessions, and you guys are going to receive an email, right, about it. And then, Marty, there was a question about a GitHub, whether we have a GitHub for the demo, right? So Keith is answering that. We have the demo is in a Live Labs workshop. So in one way, it is in a GitHub, but it's part of the workshop. So it's very easy to work with it and see it. And you can see it for free, and you look at all the code and documentation and information there. So I think it's probably the best way to look at it is through the workshop, right?
Absolutely. Yep. Yep.
All right. So I think that's it. So for now, then we are going to say that we have these sessions upcoming, right? Data Studio, and then data sharing after that. Again, if you guys go back to the site where you came today, you're going to see the sessions there, and you can subscribe to those sessions there. All right. And I'll wait. Keith is answering one last question there. But again, thank you guys very much for joining today. Really appreciate it. Thank you very much, Marty, for the session. It was great. And thank you, Keith, for handling all the questions and answers there and helping us with the links. All right. Thank you very much, guys.
Thanks, everyone.
I think that's it for today. Thank you. Appreciate it. Talk to you guys in a couple of weeks.